So question 2 here, slightly different setup. We're given the angles on the diagram, and somehow we need to turn this information into gradients of the three lines that make up the triangle. Now, that's going to take a little bit of work to do. The easy one to do here is AB, so we might as well start off with the easy one. Well, the gradient of AB is equal to, and that's the angle that's between the horizontal and the line AB. So that's easy, because it's just tan of 45. And tan of 45 degrees, putting that in the calculator, gives us 1. So we've got a gradient of 1 for AB. Things get a little bit trickier, but the next one that we've got on the line, coming up is AC. Well, the angle we're interested in is that one, because that's the angle between the horizontal and the line AC. Well, we can find that by working out this missing bit here. 50 add 70 is 120. So we must have 60 degrees as the third angle in our triangle. So that means for B, we can work out that MAC is tan of, and, oh, sorry, I've kind of confused my label. 60 is this bit here, plus the 45. So we're doing a tan of 145 degrees. 145? 105 degrees. Oh, if I could say the right thing. And we just put that in the calculator. And tan of 105 gives us minus 3.73. And that's our gradient. Now that makes sense. This looks like a negative gradient. It's definitely coming down. And so that makes sense that that would be our gradient of that line. The third part to this is definitely the hardest one, the gradient of this line, because there isn't really a horizontal to think about. Now, there's two places you can draw it. You can either extend this line until it meets over here, but at the moment, I'm just going to draw that horizontal line on. That is parallel with this line down here. Now, this is where all your angle facts from way back in kind of second year start to come into play, because thinking parallel lines, Z angles, if this is 45, then this is 45. If that's 45, well, this bit up here makes up 70 degrees altogether, so that bit is 25. Now, we want the anti-clockwise angle from the horizontal to there, so we're doing 180, take away our 25, which is 155 degrees. So lots of angles work to do here. Actually, the gradient stuff is in some ways the easy bit. And it's just figuring out what angle we're interested in and how to get it. So now MBC is equal to tan of 155, tan of 155. Again, it's just a matter of putting that into the calculator and seeing what you get. So tan of 155 is minus, which is good. That looks like a negative gradient, 0.466. And I'm just giving that to three significant figures. Really bad practice here, and I apologize for that. I should have given a full number and then a rounded answer for a good measure. So apologies for not showing quite that full process. Now, we've got a part 2 to this question. You can see I've added a part 2, but it's something that is an important skill. Given that B is the 0.64, so we're given this extra piece of information about the point B, then find the equation of the line BC. Well, to find the equation of the line, we know that the gradient of BC equals minus 0.466. We know that B is this 0.64. Well, if we know a gradient and a point, then we can find the equation of the line using y equals mx plus c. Or, in a minute, I will do the other version. You only need one of these two. So y equals minus 0.466 x plus c. And putting our numbers in, we get 4 equals minus 0.466 times 6 plus c. And working that out, we're adding 6 lots of 0.466 onto 4. And so you get, now it's not a pretty line, this one, 6.796. So our final equation is y equals minus 0.466 x plus 6.796. As I say, not a pretty line, but there's the equation. You could do exactly the same process using that. You will end up with an equation that is equivalent to that one over there. If you're stuck with that, or if there's something about using this that you want me to show in more detail, please ask. I'll finish the detail on that. But hopefully by now you're comfortable using whichever one of these, and you could check that you can work through it and get to this point here. So that is example number 2. Example number 3 is coming up in the next video. Again, just one little adaptation of things that we already know using this angle gradient connection that we've now got.